And after making 300 videos, Kukla finally realized that if he put his AirPods in, then suddenly people could hear him. Oh my goodness. So here's where the last video froze for some reason. And here it is. And I had said that we need to know this, this, and this in order to find that. Well, conveniently, we've been told that B is 24 and the dB/dt is 7. But what about H? Well, luckily, we know the Pythagorean theorem. And we can solve Pythagorean for H when I plug in that B value of 24. So I'm going to have 24 squared, Mr. Kukla. Pythagorean theorem, they're all squared. So 24 squared plus H squared equals 25 squared. I believe that's 576 plus H squared equals 625. And so H squared equals 25 and 24 is 49. And so H equals 7. So I'm taking a 7 and plugging it in here. Well, isn't that interesting? Times 7. Any thoughts on what that number is going to be? So I'm solving this equation for dH dt, which means I want to move all this stuff over here. And so I've got 2 times 7 times dH dt equals negative 2 times 24 times 7. And you may say, well, Mr. Google, why didn't you multiply? Well, because the next thing I'm going to do is divide by 2 times 7. And then those will cancel, and those will cancel. And I get that dH dt is negative 24. And it makes sense to me that dH dt is negative because I'm headed toward that intersection. Okay? Okay, so let's do part B of this problem. At what rate is the area formed by this triangle changing at that moment? Well, area is 1/2 base times height. And I know dB dt and B. And if I come and take the derivative here, I'm going to have A prime equals 1/2 B times dH dt plus 1/2 H times dB dt. That's right, I had to use the product rule. And I glued these two together for the purposes of my product rule. This times the derivative of that with respect to time plus that times the derivative of this with respect to time. And I am looking for dA dt. Well, I conveniently know all these values from the last problem, so this is going to be 1/2 times 24 times, what did we have here? We had negative 24? No, yes, we had negative 24. Minus 24 plus 1/2. What was our height? What was our height? Our height was b squared plus h squared equals 25 squared. And it looks to me like h squared is 25 squared minus b squared. Oh yes, I remember now, h was equal to 7. So times 7 times dB dt. Well, dB dt is also 7. So I've got negative 576 over 2 plus 49 over 2. And if I add these together for my dA dt, I kind of don't want to. I kind of just want to leave it and walk away. Negative 576 plus 49. And that gets me to negative 527 over 2. Does that seem like a reasonable number? Well, I think it helps if you check your pre-written answer at moments like this. And that's, I just have a version that is not a fraction. So I'm going to do 527 divided by 2. And that's exactly what I have. Good. Don't forget the units, feet per second. Okay, there's station 7. What about station 8? Station 8 says a spherical balloon. So we know the volume of a sphere is 4/3 pi r cubed. We also know the surface area is 4 pi r squared. Yes, you're supposed to know those things. Tells us a spherical balloon is being inflated with helium at a rate of 50 pi cubic feet per minute. Well, what is this? How would you name this calculously? I would say cubic feet is volume and minutes are time. And so what I'm looking at here is my dV dt. dV dt is 50 pi. So then, how fast is the balloon's radius increasing? I want to know about the change in radius with respect to time when r equals 5 feet. Oh, it's a really cool balloon. So, do I have a relationship that relates r's and volumes? And I think, yeah, it's right here. So, v equals 4/3 pi r cubed. Let's take the derivative of both sides with respect to time. In fact, let's do it this way. So I can say the derivative with respect to time, the derivative with respect to time. Okay, so on the left I have dv dt, and on the right I'm taking the derivative of the outside function, bringing down that 3. Those 3's will cancel. I'll have 4 pi. Don't forget to subtract 1, r squared. But that's just taking the derivative of the outside cubing function. I still need to come and take the derivative of the inside with respect to time. So let's plug in what we know. 50 pi equals 4 pi, what was radius? 5 times dr dt. Well, there's 25 times 4 is 100 pi. So 50 pi equals 100 pi dr dt. And if I divide both sides by 100 pi, I get the very reassuring dr dt equals 1/2. And I am given units here. Radius must be feet if volume is feet cubed, and my time units are minutes. So this is feet per minute. Please make sure you include your units. Okay, so that was the first part of this question. The second part of this question says, how fast is the surface area increasing? Oh, so I want to know about dSA dt. How fast is the surface area increasing at that instant? Well, that means I want to take the derivative of this with respect to time. So I'm going to get d surface area dt equals 8 pi r. Don't forget to come and take the derivative of that inside r function with respect to time. Now, we should know this and this. Didn't we just solve for how fast is the radius increasing? And we came up with a 1/2 times 8 pi. And what about the radius? We were told that the radius is 5. And so I end up with 40 pi over 2, or 20 pi is dSA dt. You could, of course, just write ds dt or dA dt, doesn't matter to me, but I do want the units to show up here, and area units are going to be feet squared over these time units, minutes. Okay, so 20 pi square feet per minute. Fabulous. And there's our answer to station 8. Let's take a look at station 9. Station 9, ooh, angry dog. To the north of you as you cross an intersection. So angry dog is up here. You are here. You estimate that the dog is 80 feet north. So I'm going to say that that distance to the dog is 80. And you are 60 feet over here. So U is 60. East of the intersection. Yes, that's west, that's east. The distance between you and the dog. The distance between you and the dog is increasing at 20 feet per second. Well, that's a change in the distance with respect to time is 20. The dog is moving south, so that's a change in dog with respect to time at 20 feet per second. Yes, that's right. I'm approaching, or the dog is approaching the intersection, so we're going with a minus there. Okay, 60 feet per second, not 20, but 60. This one was 20 feet per second. Okay, how fast are you moving to the east? What's the change in you with respect to time? Well, what do I have that relates this distance, and this distance? Sounds a lot like the Pythagorean theorem to me. Oh, look, I've set up a situation where this is D and this is D. So I'm going to keep D for dog, and I think I'm going to call this triangle. I know. Why? Why, Kukla? Why would you do that? And the answer is because I'm capricious and whimsical. Um, I know that most of you are going to call this Y anyway, so why not just leave that at D? But no, I'm going to go with triangle and see what comes of it. Okay, so I've got this triangle here. I've got an 80 here and a 60 here. So I can use the Pythagorean theorem to find out how long triangles should be. And this is a 3, 4, 5 triangle. If I divide um, everywhere by 20, this is 3 times 20 and 4 times 20. And since this is 3 and 4, I know this is going to be 5 times that same multiplier. So I end up with triangle equals 100. Now I don't plug that in at the beginning because this is a changing quantity. So I'm only going to plug that in after I take the derivative of d squared plus u squared equals triangle squared. When I take the derivative of this equation with respect to time, I get 2d, no, stop. I get 2d times the derivative of the inside, which is dd dt, plus 2u du dt equals 2 triangle d triangle dt. And what do we know? Well, we're looking for this. This is the thing I'm looking for, which means I must know all these other things. D, that's the dog, that's 80. 2 times 80 times dt. There's the dog's change in position, so we've got minus 60, plus 2u, 2 times 60 times the thing I'm looking for, equals 2 times triangle we solved and found out was 100, and the triangle dt is 20. So I want to solve this equation for du dt. I actually do want to do that to make my life a little easier. So I'm going to subtract this 80. Oh no, I'm not. I'm going to add that. 80 times 60, 4,800. So negative 4,800 plus 60 du dt equals 2,000. So I'm going to add 6,800 to both, I'm sorry, 4,800 to both sides. And that's going to give me 6,800 equals 60 du dt. So if I divide both sides by 60, I can get du dt by itself. 200 divided by 6 is going to be 100 over 3. So there's my du dt. And units would be good on that. 100 over 3, and these are feet per second. Okay. Are you going faster than dog or slower than dog? 60 is bigger than, I'm sorry, negative 180 is bigger than 100 if I make a common denominator. Dog's running much faster than you. You might want to get a move on. Okay. Oh, and did you notice on that problem that du dt was positive? So as you go away from the intersection, our rates are positive, but remember when the dog was running toward the intersection, I put a negative in there. You really do need to be thinking about that. Okay, next, station 10. Station 10 is going to be f of x equals x to the 1/3 which, we think of as cube root of x, but the calculus is much easier if I use that. And we're only interested in the interval from -1 to 1, it seems. So if I think about this graphically, briefly, cube root of x, yoink, yoink. Hey, look, an undefined slope at x equals 0. But otherwise, everywhere increasing, though we only want to go from -1 to 1. So the rest of this doesn't exist. And we're just looking at this part of the graph. Okay, I wonder what this question will be about. Show that f of x on this interval, it does not satisfy the mean value theorem. Well, what were the preconditions for the mean value theorem? That f is continuous on the interval. Well, I know this function is continuous everywhere from -infinity to infinity. So I can just state that f is continuous on -1 to 1. But what was the second part? Is that f is differentiable at every point on -1 to 1. And that's not true. We have an undefined slope here at 0, therefore it's not differentiable everywhere between -1 and 1. But many students don't see that. They have to actually say, I wonder, let's make f prime. And so then they bring down that 1/3, and they subtract 1. And so then they have 1 over 3 cube root of x squared. And they say, aha, I can't have a 0 in the denominator. So f prime does not exist when x equals 0. So because of that, I do not meet the preconditions. But luckily, we were told to show that on this interval, our function does not satisfy the hypothesis of the mean value theorem. Good, we're done. Graph f and its line connecting. Whoa, I want to connect this point with this point, they say. Okay, so here's my f, -1, -1, and 1, 1. But now they want me to draw a line that connects those, and that line should pass through the origin. And what do they say? No, that's it. Just graph those two things. Fair enough. Find any value c that would satisfy the mean value theorem. Well, I see a place where the slope here would be parallel to that secant line. I see another place over here. What? Oh, son of a bitch. Station 10.